In this video, we're going to be talking about rounding. So just to introduce us to the concept, a really simple introduction question. Round 17 to the nearest 10. So 17 is right here. The 10s that are surrounding 17, we have a 20 and we have 10. So we have to decide which of those 17 is closest to. So I've pulled out this number line because I think it's really visual for you to see that 17 is clearly closer to 20 than it is to 10 in this example. So our answer would be 20. 17 is close to 20. Remember, rounding is finding a number it's close to. It's something we use a lot in real life, so I think it's a really valuable skill. We're going to teach it to you in a way where it's kind of using a rule to get you familiar with it. But the whole idea is just to be able to think, okay, that number is close to this. So when you're in the store and you're trying to figure out pricing or something, it gives you an approximate answer. So the rule we use, if you don't want to draw a number line every time, is you're going to underline the place value you are rounding to. You obviously don't have to do these steps, but I find this the easiest way for students to sort of practice it. So it's asked us to round 17 to the nearest 10. So I'm going to underline the tens place. Then it says circle the digit to the right. So the digit to the right is the 7. Now, if that circled digit is 0 to 4, the underlined digit would stay the same. If the circled digit is 5 to 9, it'll round up. So our circled digit is obviously in this 5 to 9 category. So we would round up the 1. What's 1 higher than 1? Obviously 2. And then any numbers behind it, so to the right, become a 0. We already established that 17 rounds up to 20. So we've just sort of used our rule here to prove again that 17 rounds to 20. Miss Cooper, what if we're rounding the number 15? You've said that the 5 rounds up, but why? It's in the middle between 10 and 20. One way to think about it is, in terms of these digits, 0 to 4, so if it ends in 0, 1, 2, 3, or 4, the first digit stays the same. If it ends in 5, 6, 7, 8, or 9, it rounds up. So if we count those, that's 1, 2, 3, 4, 5 digits make it stay the same. 1, 2, 3, 4, 5 digits make it round up. So even though it seems like 15 is right in the middle, which it is between 10 and 20, in terms of rounding, it does fall on the side where we round up. So try and remember that. The 5, which seems to be the trickiest for kids, requires you to round up. Let's do a couple more practice questions. This example says round 14 to the nearest 10. So I've indicated where 14 is and where the surrounding 10s are. Hopefully you can see visually that 14 is closer to 10. So our answer is going to be 10. Just using that rule to reinforce it, I would underline the 10s column because that's what I'm trying to find. I'd circle the 4. The 4 indicates to me that 1 is going to stay the same. The digits after it become zeros. 10. Although a simple example, this often sort of stumps kids. That's why I wanted to throw this example in there. Round 3 to the nearest 10. So there's our 3. There's 10. But what was the lower end? In fact, I had to add it in here. It's kind of a weird thing to think about, but if we're rounding down, the nearest 10 would be 0. So in fact, if we look, 3 is clearly closer to 0 than it is to 10. Now, if you were answering a math question in class, yes, the answer to this question would be 3 rounded to the nearest 10 is 0. But if you're out at the store and you're trying to figure out a price, you probably don't want to round your answers to 0. So be aware of that, where you're using it, what the context and circumstances are. This example says, what is $911 rounded to the nearest $10? So I've put in a number line here that goes from 910 to 920, indicated where 911 falls. I think it's pretty easy for you to see that 911 is clearly closer to 910, so our answer is $910. Using our rule down here, just going to indicate that. Okay, it wants us to look at the nearest 10. So I'm going to underline the tens column, circle the digit to the right, looking at our key. If this digit that's circled is a 0, 1, 2, 3, or 4, the underlined will stay the same. So, Miss Cooper, what about this 9? You have to keep that. If you just write 10, that's not going to help you. We want to say $911 is close to $910, not to $10 itself. And then the circled digit and everything to the right becomes a 0. See, sometimes it's helpful to use this rule if you're good at memorizing, but I found it a lot easier to look at a number line. Either way, our answer comes out to be 910. In this example, it says, what is 2,923,276 rounded to the nearest million? So I've drawn here a number line where we have 2 million on one end, 3 million on the other, and I've done intervals of 100,000, so 2,100,000, 2,200,000, etc., all the way to 2,800,000, 2,900,000, and then 3 million. I've placed in there 2,923,276. So I think it's pretty clear, again, from this number line, that if we're rounding to the nearest million, 3 million is much closer to 2,923,276 than 2 million is. So our answer is 3 million. Just checking that with our rule, because it might be easier than drawing a number line. It says, first we need to figure out, we're going to underline the nearest million. So it wants us to find the million. We're going to circle the digit to the right. We're going to check, is that digit between 0 and 4, 5 and 7? It's between 5 and 7. So what's 1 higher than 2? 2 is going to go up to 3, and everything else is going to change to 0. So according to our rule, our answer is 3 million, and according to our number line, it's visibly closer. This example says, what is 127,610 and 31 cents, or dollars here, rounded to the nearest $100? So I've written $127,600 on this end, our number line, $127,700. So really it's between $600 and $700. We're going the nearest 100. And then I've done it by $10 increments. So this is 127,610, 620, 30, 40. Here you can see I've added this one in. $127,650, $60, $70, $80, $90, and then up to the 700. Again, very clear with the number line. What is it closer to? It's clearly closer to $127,600, so I'll write that in. Rounds to, it's about $127,600. Let's go ahead and prove it using our rule again now. So it wants us to go to the nearest 100, so I'm going to underline the hundreds digit. I'm going to circle the one to the right. Now that digit, the 1, is clearly 0 to 4, so the 6 is going to stay the same. So I'm going to keep the 6 the same. Everything to the left, yes, it's still 127,000, obviously. Everything to the right goes to zeros. So $127,610.31 is close to, or rounds to, $127,600 when we're rounding to the nearest $100. In this last example, it says, what is 5,263 rounded to the nearest thousand. So we have here a number line with 5,000 at the beginning and 6,000 at the end. I've gone up by hundreds in each increment or interval. So 5,263 would be about here between 5,200 and 5,300. So obviously, based on where that is on the number line, it is closer to 5,000. Closer than it is to 6,000, obviously. Using our rule, I'm going to underline. We're looking for the nearest thousand, so I underline the thousands. I'm going to circle the one to the right. It's a 2. That suggests the 5 is going to stay the same. And the numbers turn to zeros. So 5,000, and it matches. Okay, that's it for this section. Good luck.